Calculus, lesson 4. Now things are about to get interesting. We've got a lot of the more boring stuff from calculus out the way. Now we're going to start taking on some new and different equations, and we've got some new methods and rules that we will actually be learning in order to solve them. First one we're going to touch on is the chain rule. Now the chain rule, let's look at when we actually use it relative to what we know so far. So we know basic differentiation, and that was when we had y equals x to the n. So any sort of indice, x to the 3, x to the minus 4, x to the half, any sort of indice, you just bring down the power minus 1 from the power. That we've got. Now, chain rule. Chain rule we do when we've got, instead of just a single term to an indice, we've actually got a whole function. I call it g of x just to represent a whole function. Now that could be 2x minus 1, 1 minus 3x squared, that sort of thing. It's a whole function to the power of n, not just a single indice. So that's when we use it. Now, how do we use it? Here's chain rule. It actually works in the exact same way to start off with as what we know. So we bring down the power, we bring down the n, we minus 1 from the power, and then the only difference is, and this is why I like to think it's called chain rule, is you've got to make sure you don't forget your chain. Okay, and what your chain is in this case is you need to times by the derivative of that function in the brackets. So if we call that g of x, the derivative is g dash x. So everything's the same as we've learnt it. You bring down the power, minus 1 from the power, the bracket stays the same. But with chain rule, make sure whatever you do, you don't forget your chain. And your chain is just the derivative of the function that was in the brackets. Okay? If that makes sense in general form, we're doing well. And it'll make a lot of sense in numeric form. But if not, push on and see if you catch on with the numbers. So we're going to do an example. Y equals 2x minus 1 all cubed. So you can start recognizing chain rules because you're going to have these bracketed functions to an indice. Okay? So in this case we recognize it's a chain rule, and what we do is the first part is exactly as we know it. So you bring down the power, minus 1 from the power. So bring down the 3 and minus 1 from the power. So it's 3 outside of 2x minus 1 all squared. But now what makes a chain rule is you've got to include the chain. And the chain is the derivative of 2x minus 1. The derivative of 2x minus 1 is 2, because the minus 1 disappears. So our g of x there is 2x minus 1, and we attach our chain, and our g dash x is the 2, as you can see. Once we've done that, our next step is just simply combining times in those two loose terms out there, which is the 3 and the 2. So we're left with 6 outside of 2x minus 1 all squared. And that's the derivative. Let's try another example. Differentiate f of x equals 3 minus 8x all to the 5. Now again, we recognize it's a chain rule because it's a bracketed function to a big indice. And what do? We operate in the exact same way. Bring down the power, minus 1 from the power, and then times by our derivative of that bracketed function, which is, in other words, I like to call that our chain. So multiply on our chain. So let's do that out. We bring down the power, we minus 1 from the power. So it's 5 outside of 3 minus 8x to the 4. Now we've got to remember our chain, so we times by the derivative of 3 minus 8x. What's the derivative of 3 minus 8x? It's just minus 8. So we now times through our loose terms, as I like to call them, and that leaves us with minus 40 outside of 3 minus 8x all to the 4. And that's the derivative. Done. Next one. Okay, differentiate f of x equals 3 plus 2x all squared. Now, it looks a lot like a chain rule, and ultimately you could absolutely do this as a chain rule and work in the exact same vein. And I'll even show you that chain rule option right after. But for me, and the fact that it's a 2 and not a bigger indice. So what I want to do is I want to add this little rule, and I'm going to put it in our formula bar there. And that is, if you can combine your function, so if you can expand or simplify your function, always do. In this case, we could expand it because it's just a square, and we could quite easily expand a square. Whereas if it was a 5, like the example above, you're not going to be able to expand it, so it's a straight out chain rule. So with this one, as I said, you could do chain rule, but if you can combine it, if you can expand or simplify it, then it'll often make life easier for you. So that's the route I want to go here. We're going to expand it. And we do that by doing the first squared, which is 9, plus twice the product, so 2 times the product, which is 6x, plus the last squared, which is 2x all squared, which is 4x squared. Then tidy it up in the next line, so you've got 9 plus 12x plus 4x squared. So we've still got our f of x there. We haven't yet differentiated. But it's now very easy to differentiate. We don't even have to use chain rule. We can just use our basic standard differentiation. So that differentiates into the 9 disappears, 12x becomes 12, and 4x squared becomes, bring down the power, 8x. So our derivative of that is actually 12 plus 8x. Alright, now as I mentioned before, you can also do this using chain rule. And I'll show you how that's done. So the other option is use your chain. We know how that works now. We bring down the power, minus 1 from the power, and we times by the derivative of the bracket. Don't forget your chain. So we bring down the power, minus 1 from the power, so it becomes 1, and we times by the derivative of the bracket, which is 2. And so when we tidy it up, that is 4 into 3 plus 2x. And one more expansion leaves us with 12 plus 8x. And what do you know? Exact same answer. Which just shows with loads of these differentiation questions, you will find that there's more than one way to skin a cat. You can actually do a couple different options. So whatever you see as easier, whatever's more natural for you, go for it. Alright, next one. F of x equals 2x squared minus 6 all cubed. Now we look at that and we think to ourselves, well, can we combine it like the one above? Well, not really. I mean, unless you want to go expand the cube out, which is pretty tough. So the best way to do this is obviously chain rule. So what we do is bring down the power, minus 1 from the power, and then you've got to remember your chain in chain rule. That's the one important thing. Remember your chain, and your chain is the derivative of what was in the brackets. So what's in our brackets there? 2x squared minus 6. The derivative of that is, say it out loud, 4x, because the 6 disappears. Then let's tidy up our loose terms, times the 3 by the 4x, and we're left with 12x outside of 2x squared minus 6, all squared. You can leave it like that. Beautiful. Now, time to try a few miscellaneous examples. Miscellaneous being they could be chain rule, they could be standard differentiation, they could be anything. So you're not going to get told in a test which rule to use. So I want to start getting your feet underneath you, and I want you to start thinking on your feet and picking up what the particular question is and you choosing the right method. So for these, and you can see icon in the top left, try it yourself. Pause them after each one. Do it yourself on paper and cross-reference it with mine. So first one, differentiate 3 into 1 minus 3x cubed all to the power of 4. Okay, so I'm throwing in some more numbers, some cubes. I'm just trying to intimidate a little bit. But don't be intimidated. Just play it out as we do. We notice it's a chain rule because we can't expand or simplify. We can't combine that. So what we do is we treat it as a chain rule. We bring down the power, minus 1 from the power. 1 minus 3x. So first part is q. Bring down the power. The 4 times is by that 3. We get 12 into 1 minus 3x cubed, all cubed. And then make sure with chain rule you don't forget your chain. And your chain is just the derivative of the bracket. And the derivative of the bracket, the 1 disappears, and that becomes minus 9x squared. Tidy up the loose terms, times them out. We get 12 times minus 9x squared is negative 81x squared into 1 minus 3x cubed, all cubed. So here we've got differentiate y equals 2x outside of 6 minus 5x all squared. Remember, looking in our side column there, combine if you can. So if you can expand or simplify it, do so. In this case, we've just got the squared, so we can square that out first and then expand the 2x in. And that's what we'll do. So 2x into, let's square the first, twice the product, square the last. So square the first is 6 squared plus 2 times the product, which is negative 30x, plus the last squared. And then we'll do that properly in the next step. I don't like skipping steps, as you've probably learned by now. So we've got 2x into 6 squared is 36, 2 times minus 30x is negative 60x, and negative 5x all squared is plus 25x squared. Next step, we can now expand the 2x through. So that gives us 72x minus 120x squared plus 50x cubed. The derivative of that, now 72x becomes 72. Minus 120x squared, bring down the power minus 1 from the power, so it's negative 240x. And 50x cubed becomes, bring down the power minus 1 from the power, 150x squared. And that is the derivative. So in this case, you had to combine, you had to expand it in order to be able to solve that one. Alright, last example. Differentiate f of x equals x into 2x minus 3 to the 4. Now here we have a situation, unlike the previous one where it was the function was squared and we could square it through and expand it. Here it's to the 4. So we look to combine it, but it's actually not combinable. Which begs the question, what if you do have two multiplying terms? And by terms I don't mean numbers, I mean x's or functions of x. So here we've got x multiplying by 2x minus 3 to the 4. What happens if we've got these two multiplying terms that are not combinable? Well, we can't do this based on what we know so far. We actually need a new rule for questions like these. And that new rule is product rule, which will be what is in store for you in lesson 5.